Okay, when we were last together, we started to learn how to balance chemical equations, and you were asked to do page 49 and 48. Yes, in that order. So today you're just going to have mostly a work period. I'm going to give you a quick reminder of how to do some of the steps for balancing chemical equations, and then hopefully that doesn't take too long. So I'm going to start with this one, which is the number one from page 49. When you take a chemical equation, you start with the most difficult one. I'm going to outright say that is the most difficult chemical equation. And then you start with the actual compounds. Now, in this case, you have a polyatomic ion on one side, the ammonium, and a polyatomic ion over on the right-hand side, also ammonium. So write down the nitrogen and hydrogen as a collection of ammonium. So on the left-hand side, the reactant side, we have 3 ammoniums. On the right-hand side, there is only 1 ammonium because there's no number between that 4 and the following N. So we're just going to assume that is 1 because we don't bother writing number ones. I also noticed, since I'm starting with this really hard one, the ammonium phosphate, that the phosphate on the reactant side is the same as the phosphate on the product side. And so we don't have to break apart the phosphorus and the oxygen. So write it down as PO4 on both sides. So on the left-hand side, there's only 1 group of phosphate. On the right-hand side, there's only 1 group of phosphate. Then you move to the second compound on the left-hand side that you haven't touched yet. And so we have aluminum, only 1 aluminum. And on the right-hand side, there's only 1 aluminum because there's no number next to each of those aluminums. And the last compound is the polyatomic ion nitrate, which stays as nitrate on both sides. The left-hand side has 3 individual nitrates. The right-hand side has no parentheses and therefore no numbers after that 3 for the NO3. And so the nitrate remains as nitrate. 3 on the left, 1 on the right. And then you just go through the process of balancing. So start off with your ammonium, multiply the right-hand side by 3. And again, whatever number you stick out front is the number that you multiplied by, not the answer. So I now have 3 groups of ammonium, but that also means I have 3 groups of nitrate. So I have to multiply the nitrate at the very bottom by 3. What that does is it fixes the nitrate, so I don't have to worry about it. So nitrate is solved for, and then I look at all the other ones. I have 1 phosphate on both sides. I have 1 aluminum on both sides. This one doesn't require a lot of work. It just looks very intimidating. On page 48, you will have a whole bunch of words equations, so a bunch of sentences where you have to actually write down the skeleton equation, then you have to balance it. So that can be a little bit of a chore because it requires knowing the different types of chemical compounds. So this one is barium chloride and magnesium sulfate combined to produce barium sulfate and magnesium chloride. And I think, I'll just go back 2 slides. I think that's number 5. And I'm going to do number 10 as well next. So that's number 5 from page 48. So barium chloride is an ionic compound because barium's a metal. So when you look up barium, barium should be a positive 2 charge, and chlorine is a negative 1 charge. And since they're different charges, you're going to have to crisscross them. So when I write it out, I'll go BaCl2. And magnesium sulfate. So magnesium, once again, is a positive 2, and sulfate is a negative 2. So magnesium's a metal, therefore it's going to be an ionic compound. Sulfate's a polyatomic ion, and I know because it ends in 8. So when I put them on there, I've got MgSO4, and I don't have to crisscross charges because they're both 2. So magnesium has 2 electrons to give away. Sulfate is looking for 2 electrons. They're happy the way they are. If you want to use parentheses, go ahead. It's not necessary. I'm going to undo mine. So they react, combine, which means arrow now, to produce. So that's how I know it's on the right-hand side. Barium sulfate. So barium is still a +2. That doesn't change. Sulfate's a -2. So I can just write it as BaSO4. No need to crisscross these ionic compounds when they have the same numbers. And then write out magnesium chloride. Magnesium's still a metal. It's still +2. Chloride is still a non-metal. It's still -1. We will have to crisscross. And then just write it down as MgCl2. And then you look at it and you check to see how it is for balancing. The most complicated looking one is a toss up between the magnesium sulfate and the barium sulfate. So it doesn't really matter which one you start with. If I start with magnesium sulfate, I'll go MgSO4. And I'll notice that there's one magnesium on both sides. There's one sulfate on both sides. If I then write out what's left on the left-hand side, because that's the side I started on the reactant side, I have barium and I have chlorine. And barium has 1 on both sides. And chlorine has 2 on both sides. In a case like this, where we notice everything is already balanced, I didn't have to put any numbers. I don't have to multiply everything. It's already balanced. You don't have to do anything. If later you want to remind yourself, if you look back on your homework, that this one was already balanced, you didn't just forget about it, maybe even just write down somewhere nearby, already balanced. And then move on. And then you know you don't have to come back. Number 10, I think it was, says solid cesium iodide reacts with liquid bromine to produce solid cesium bromide and liquid iodine. If they don't give you the states, I don't really expect you to put them in. But when a question outright tells you what state they are in, solid, liquid, you should have the states visible as well. So cesium is a metal. It is all the way on column 1A. It is element number 55. It is a +1. Iodide, IDE means I'm just looking for iodine. That's a -1. So it's ionic compound. I'll just write it down as CSI. Big capital I, don't forget the serifs. And it's solid, so give it a little S. Reacts with liquid bromine. So liquid bromine, little cursive L there for liquid. And then if you look at bromine on the periodic table, you will see that it has a circle around it. And the circle means it is a diatomic. So if it's by itself, you have to have a 2 next to it. It produces solid cesium bromide. And so therefore, +1, -1, you don't need to crisscross. So you end up with CsBr, that's solid, so put an S, and liquid iodine. So once again, it says liquid, so I'll use a cursive L. But again, just like bromine, iodine has a circle around it, so that means the diatomic, so you have to have a 2 next to it. Once you get that far, you balance. And then again, it doesn't really matter which one you start with. Always start with the most difficult one. And so it's a toss-up between cesium iodide or cesium bromide. I'll start with cesium iodide just because it's on the left. Not that that matters. That's just what I choose to start with. State what you have. Cesium, it, of course, has only 1 on both sides. So cesium's already balanced. Iodide has 1 on the left. Iodine has 2 on the right. So that one's not balanced. So before you do anything else, just finish writing down whichever chemicals you haven't written down yet. Bromine on the reactant side is 2. Bromine on the product side is 1. And then you balance. Cesium you shouldn't have to touch, at least not yet. Iodine, we have to make this 1 a 2, so multiply by 2. And that means you put the 2 out front. So that ends up messing up our cesium. So because I put a 2 out front of cesium, I now have to make that adjustment. I have 2 cesiums on the left. It is no longer balanced. I now have to multiply the right-hand side by 2 to fix that. But in doing so, by fixing my cesium, it now means I have two bromines as well. And so that just outright fixes my bromines before I even look at my bromines. And then you have yourself a balanced chemical equation. So again, and the question that tells you what state it's in. So do write it down as good practice. I have just a couple more and then I'll stop this video. Pause it if necessary. I realize I might be going quick. So here we have ammonia. Ammonium is NH4, my bad. You have ammonia reacting with sulfuric acid. So that's this guy here. I know it's an acid, starts with hydrogen. And that produces ammonium and sulfate. So we call it ammonium sulfate. Now in this case, the NH4 is not the same as NH3, so we cannot treat it as a polyatomic ion. We have to break apart the nitrogen and the hydrogen. Whereas sulfate remains as sulfate, so we can leave the sulfate alone. So I am going to start with the right-hand side because that looks like the most complicated one. So when I write it down, I'm going to write it down as nitrogen, then hydrogen, split up. But then I'm going to write down, actually going to leave a gap, and I'll explain that in a moment. Then I'm going to have my sulfate written down next. And then you do a quick little count. So nitrogen on the right-hand side, there's a 2. I'll change colors. There's a 2 right here, which means you have to have 2 nitrogens. That's what you start with. And because there's a 2 right here, it means you have 2 ammoniums. So that 2 times 4 is 8. So we're starting with 8 hydrogen and 2 nitrogen. The sulfate, there's no number outside of the parentheses I added. SO4 is a sulfate, so we have 1 collection of a sulfate. Then when you compare on the left-hand side, we have 1 nitrogen only. Hydrogen is in 2 different spots, and that's why I left a gap. Hopefully you did too. So the first hydrogen has 3 groupings. The second hydrogen has 2 groupings. So as a running total, I have 5 hydrogens on that left-hand side. And then when you look at the sulfate, you have 1 only. So this one can look a little complicated and intimidating, but just start from the beginning, start at the top and work your way down. I need 2 nitrogens, so I'll put a ×2 here. And that 2 has to go next to this nitrogen on the left-hand side. And therefore the nitrogen on the left-hand side and the hydrogen on the left-hand side are also multiplied by 2. So if I put that 2 up front, I have to put a ×2 next to the 3 for my hydrogen. And so that means I now have 6 hydrogen. When I compare it to the other hydrogen that I haven't touched yet, I still have 2. So if I take that 6 and add it to a 2, that gives me 8 total hydrogen. And so at that point, I compare that to the right-hand side and I go, oh, good, I have 8. And then the sulfates balance out, so there's nothing more we need to do. This one's done. So again, sometimes you're allowed to leave your polyatomic ions untouched, like you did with sulfate, and sometimes you'll have to break apart your polyatomic ions, and you cannot leave them untouched. That's just the way it goes sometimes. All right, this last one is a bit of a harder one. You might have a few that look like it, but if you follow my steps, you'll find they're not that bad. So this is when you have a combustion reaction. You have a fuel added to an oxygen will always produce water and carbon dioxide. And these combustion reactions always start with your hydrocarbon. So I have 3 carbon on the left, 1 carbon on the right. I have 6 hydrogen on the left. I have 2 hydrogen on the right. Then you have oxygen. On the left-hand side for oxygen, it's a diatomic. You only have 2. Since it's a diatomic, I definitely want to leave that one for last. On the right-hand side, it's in 2 spots. I have 1 attached to hydrogen. That comes in a grouping of 1. Not that a group of 1 is, but whatever. My other one is the one that's attached to my carbon dioxide, which means I have 2. So I have a total, always keep a running total, of 3 oxygen. on the right-hand side. Most of this is easy until you get to oxygen. So to fix the carbon, multiply the right-hand side by 3. You put a big 3 out front, and that affects the oxygen that goes up by 2. So update that oxygen that goes up by 2, multiply it by 3. You end up with 6. Your number here changes. You now have 7 total oxygen, but ignore the oxygen till the end because it's diatomic. Hydrogen, I have 6 on the left-hand side. I'm going to have to multiply this 2 by 3 just to get to 6. So I'll put a 3 out front. And that 3 is going to directly affect the single oxygen. So if I multiply that by 3, should work out. I end up with 3. And then I end up with 3 plus 6 gives me 9. Now that is not great because I can't multiply this 2 by anything, have a whole number, and get 9. And we only ever want whole numbers in our balanced chemical equation. So we have to think about what else we could do. My quick fix is to ignore that rule for a brief moment in time, multiply it by 4.5 in this context. So 4.5 times 2 should give you 9. And then lightly with a pencil, just kind of put it in there really lightly. You end up with 4.5 oxygen molecules. Now we can't leave it like that because you can't have 0.5 or 0.2 or point whatever in your balanced chemical equation. But it is mathematically balanced. So at this point, all you have to do to fix that 0.5 is to double everything. Doubling everything will get rid of a half of a number. So that means I have to multiply everything by 2. My propene is multiplied by 2. My 4.5 worth of oxygen is multiplied by 2. 4.5 times 2 is 9. My 3 waters times 2 gives me 6. And my 3 carbon dioxides times 2 gives me 6. This is your final balanced value. So again, to reiterate, you do not want half numbers for your actual balancing. The best way to fix that is if you're positive everything is balanced as far as you can go, but you end up with a 0.5 somewhere, is just to double everything when you are done. Feel free to check, but you guys have some practice you should do now on page 48 and 49. If you're not done all 30 on 49, get at it. If you're not done the, 20 on page 48, get it done ASAP.